How's it going, everybody? I want to thank you guys for stopping by and hanging out with me in this video. If you could go ahead and do me a huge favor and please like, share, and subscribe on the video, be much appreciated. Thanks, guys. How's it going, everybody? In this video, we're going to continue our Let's Talk About Networking series, where we're going to dive into another topic area for CCNA and CCNP candidates that revolves around the campus LAN. So this is typically an area of frustration that I've seen several people struggle with. And I was like, okay, well, why do people struggle? And so as I was doing a little bit of research and kind of floating around a couple of different forums, Cisco Learning Network and some other stuff that I see online, it's commonly misunderstood, where do you use trunks? Where does VLANs come into play? Where do you go routed? Where do you go switched? That type of stuff. Why would you do one thing here? Why would you do routing here? Why would you do switching here? So on and so forth. So my goal is to try to help everyone understand what is going on for the most part, right? I also I went through a lot of the feedback on the last video, and the majority of the commentary was, unfortunately, well, it was actually, I was a bit surprised, to be honest with you. The background music was apparently distracting or boring or too loud. So I was like, huh, okay. Well, some people, the background throughout the video was, the music in the background was a little bit boring, too loud, too distracting. I'm like, really? Okay. I mean, so apparently it's either, I can't get a good fix, or if it's no music, a different type of music. I don't know. I just was a little taken back by that. But I'm like, try to take it to the next level, and you guys are like, don't do that. I'm like, but I want to. Anyway, with that being said, let's talk about network design. Because at the end of the day, regardless of whether there's music in the background of the video or not, it doesn't matter. You guys need to understand the core logical understanding of what's happening in the campus, because I've met a lot of engineers that don't understand the basic concepts of, trunking, VLANs, spanning tree protocol, core networking theory that they would need to know, and they're like struggle to figure out how to make something happen. I've met more than my fair share of paper CCNAs. And let me explain what I mean by that. It's not a knock on anybody that has a CCNA, okay? If you have your CCNA, great job on earning it. But if you've earned your CCNA and you tout it around like, you should be revered because you have it, but then when it comes time to implement something, you take forever to get it done. I've struggled with that as a CCIE. I talk about it as I'm proud of it, because it's a major accomplishment for me. But one thing that I don't do is I don't say that this should work because I'm a CCIE. That's not what I do at all. So I want you guys to understand that when you've earned a certification, regardless of what it is, at the end of the day, nobody gives a crap, right? I mean, people will be happy for you and stuff like that, but nobody cares. Well, just be honest with you. It's, you're going to care. I care that I have certifications, right? But nobody else is going to care. As long as you can get the job done, that's really all, at the end of the day, that's all that matters. And if you can't do the job, or you don't do the job effectively enough, and I've been in those situations before, I've rolled out projects that didn't go well. I've had those problems before, and I'm not afraid to admit it. But I've learned from those mistakes as well. And I've had projects that don't go well at the CCIE level. So when I say that I've worked with paper CCNAs, I've worked with people that have earned a CCNA certification, but they understand some of the theory, but when it comes to actually implementing it, they have a very difficult time actually putting it into practice. And that's why when I bring this up, I bring it up as a don't talk the talk, walk the walk, right? Because, you don't want to be that person. So let's talk about the network design in all of its glory that it goes into. Let me go ahead and adjust a couple things real quick. Go ahead and grab my pen tool. So obviously we have the core, right? The core is typically going to be a layer 3 communication. So this line right here that's drawn here, this indicates a layer 3 connection. Well, how do you know that? Well, because I do. And the reason why I know that is because normally at the distribution layer, you're going to chop this guy in half vertically, or I should say horizontally. And this side right here, going north, will be layer 3, and this side down here will be layer 2, right? And on at about this level right here, you're going to have SVIs deployed to be the default gateways for all of the downstream devices. So you're going to have VLANs here. Let's say you've got 10 through 20 or 10 through 30. You've got 31 through 50, and then you've got 51 through 75. So you're going to have a number of SPIs up here configured, and that's going to allow you to provide some scale for all the connections going into all these VLANs that are applied to these ports alongside of or on these switches that you're going to have endpoints plugged into. But you might also be like, what's the deal with this and what's the deal with this? Why do I have overlap? Why is there overlap right there? Well, the simple reason for the overlap is this diagram is representing some sort of chassis virtualization. Chassis what? So you have chassis virtualization. What is chassis virtualization? There's several different variations of it. In the campus, you have, one of these days I'll learn how to write. In the campus, you have VSS, and you also have Stackwise. In the data center, you're going to have VPC. So there's also another one known as VDC, or Virtual Device Context, but right now we're not talking about that. The Virtual Switching System, or VSS, is a way to take two physical chassis like this, typically going to be larger platforms, normally a chassis like a 6500 or 4500, something along those lines. And what you're going to do is at the line card level, so this is the line card, you're going to physically wire a connection between the line cards. And then what's going to happen is you're going to set up BSS so that these two guys appear as one logical system, right? So this will be switch 1, this will be switch 2, well, it'll look like switch 1. And then you're going to be able to fail between, in the event that switch 1 dies, you'll be immediately able to fail over to switch 2. And everything will look like that, but from an upstream perspective, it'll look like this. So another variation of this look and feel would be this. Let me back this up just a little bit. So if we look at this and then we draw links down to a access layer switch like this, right? Instead of it being like this, where you have switch 1, you have switch 2, it'll be actually like this. It'll be like this. So these guys right here, here and here, will now look like this right here. So this will be switch 1. And everything will be good to go. So you're virtualizing the, basically you're making the switch look like two physical switches, making it logically look like one. Now, Stackwise is much the same way. You have a couple of pizza box switches. So basically just a 1U standalone switch. And then you have another standalone switch, right? And then you have another standalone switch that's down at the access layer. So this is your distribution, this is your distribution, this is your access. Well, what you would do is you run a cable from each switch at the distribution layer down to the access, and then on the back end, on the control plane side, you'd run what they call a stacking cable. A stacking cable is going to make switch 1 and switch 2 look like switch 1. It'll just be a switch that you log into. It's got multiple line cards in it. This is actually more commonly deployed than this style up here, because in the event that the chassis goes down and a line card dies, or a line card dies and you replace the line card in a 6500 or a 4500 and you want to slide a new line card in that gets RMA'd from Cisco, and you plug that bad boy into the chassis and then you connect it to the crossbar, which basically is the fabric backplane that the line card would connect into. Well, once that PCI slot connects into the backplane of the chassis, the slot should come online, right? It should power on and go through its boot up process and then download all of its config from the supervisor engine. Well, if that doesn't happen, then you've got another problem. Either the line card is bad or the chassis has a problem. If the chassis has a problem, that's a much bigger issue because now you've got to take that into consideration and deal with the effects of that. So another way of dealing with this is to move away from this design and strictly stay at the pizza box or the standalone switch methodology. The idea is that when you do this method, if you add a third switch, for example, right, and then we run a connection here, and then we add a fourth switch, and then we have another access layer device right here, and then this guy connects to this guy, and then this guy will connect back up to here, right? So they're all interconnected, right? Well, what's cool is this guy right here will actually look like this, and you'll see the double connections coming down like this. So this right here will then be logically represented like that. So you'll have that virtualization there, and that's what makes this happen. And then you have port channels set up here, so you'd actually port channel these guys together like so. I'm not going to get into virtual port channel or virtual device context, but that is another option for you as well if you want to do so. So how do I know this is a layer 3 port? Because in most common network designs, you cut this guy in half and you make this layer 3, you make this layer 2. These guys are trunk links that are also port channels, and then you have a bunch of VLANs configured here like 10, 20, etc. That's how that comes into play. Now, let's go ahead and move on down just a little bit further to here. So we have the 3-tier model versus the 2-tier model. So how do you do this? Maybe you're here, right? Maybe this is an interim step. So maybe this is a small to medium-sized business that is where everything is at. You don't really have a reason to go to the next level with the core distribution. This is actually very, very common in a lot of the environments that I've seen where people don't need to put in a designated core environment. But if you get into a much larger organization, this is actually very, very common because what this does not give you, this does give you. And I'll draw this out in a little bit more detail later on to help you understand more detail what I mean by that. But what's cool about it is your layer 3 here and your layer 2 here. And if you need to connect this guy to here to another set of connectivity, you just have more devices like so, and then you connect them down to more clients like this, and you scale it out, and then you would route like that to wherever you've got to go. So it makes it very, very easy to work with. Now, in this design here, we are scaling this one here because we need to be able to take into consideration what's the growth going to look like. You know, if it's a small company that's had 20 employees for the past 15 years, it's probably likely that company is not going to need this out of the gate. They're probably not going to need this. But you get into a much larger organization, you might be spinning up sites that are a full building or something that's larger where, you know, a couple of 3750Xs that you run fiber cables to between your MDF and your individual IDFs, and you try to run fiber cables down to your access layer, you might run into a problem with your connectivity. So there might be a use case where this design right here would come into play. Now, let's talk a little bit more about that in detail because I really want to spend some time on that specifically. So let's go ahead and draw this out. So if I have a situation where I've got, I'm gonna try to do my best in drawing out a full campus architecture. I'm actually gonna go ahead and get out of the way as well so I have more real estate. So let's draw the core, right? So we draw a core switch here, we draw a core switch here, and we want to say core and core. Well, this is the core, and we run cables to these guys like this. Maybe we run a port channel if it's layer 2 connectivity and we're doing a bunch of SPIs, but for the sake of argument, let's say we're not doing that, but these are 2/30 links sitting between these guys, right? /30 there as well. Well, what I can do is I can break the network down into different modules. So let's say over here I'll just write a D and a D and then an A for access, right? So I'm just going to draw lines to help me interconnect all of this instead of just doing squares. And then you would run from D to D like so. Right? So you have all your interconnections. This would be one module, right? And then these would be layer 3 links here. All these links would be layer 3 because you want to route between them. And then down here, you would split this guy in half. Let me split the D in half a little bit better. And this would be layer 3 connectivity, and this up here would be layer 2 connectivity. Now, this could be the DMZ. DMZ, or demilitarized zone. This is where all your servers that are going to sit for internet-bound access. Let's draw another one out. Let's draw but we're going to draw it out a little bit differently. We're going to say D, and we're going to say D, and then we're going to have access here and access here. Now, what I'm going to do is I'm going to run a cable here, and I'm going to run a cable here, and then here, and then here. Right, these are going to be all layer 3 links, and then I'm going to run a connection here to here and here to here. Now, this could be something else, whatever it is that you deem it to be, right? That could be another system that you put in play. Now, there comes a time when you need to be able to connect to the internet and the WAN. So let's say we put the internet module out here, and then we put the WAN module over here. Do you need to put the same configurations out here that you have set up here? In most cases, no. But normally on the internet and the WAN, actually, that'll work. I'll say that, let me draw this out real quick. We'll put in here, we'll say D, 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 D for distribution for internet, and then we'll put router, and we'll put router, and I'm also going to put in here, in this case here, firewall. Actually, let me do it this way. Let me do firewall, router, and then router, firewall, and then we'll do router, and this will be WAN, and this will be internet. And then we'll run cables to each one of these, like so. And then like that. And then we'll run connection down to here, like so, and then we'll be connected like this in the event that there needs to be that. And then we'll have a connection coming down to here, connection coming down to here, and so on and so forth. And then we run connections like this across the board. And then this would obviously connect out to, we would have MPLS or something like that set up, and then we'd have site 1 and site 2, and then maybe DC over here, and then we would run connections to each one of those locations, and then we would have connections going to we'd have 2 routers peering to the provider. Maybe we have 2 MPLS service providers. And then the internet side of the house, let's say we have ISP1 and you have ISP2, and you have, we have site 4, we have site 5. And then we do connections up here to this guy, and then down to here, and then this guy connects down to here and here, and then this guy dual connects to there, and then we have connections to here, and we have connections up to there. But then you might say, well, why do we have a router and a firewall? Why is that there? Well, the reason why you would have a router and a firewall, and then you have a firewall over here, maybe this is your internet connectivity going outbound, right? And then you have a firewall here doing all of your inspection. So think of it like this. If I have a scenario where I have internet connectivity going out and I need to be able to take that data and I need to inspect it, whether it goes through a firewall or some other scenario, I need to be able to inspect whatever it is that's going through the firewall. Well, firewalls are great, and if I don't want to do anything elaborate with them, I don't really have to. I can simply say, you know what, I'm going to create a default route on the firewall to the point to the router, and then the router will take that route, and maybe he's doing BGP. Maybe he's just got a full internet routing table. and everything's great. But maybe he's not running BGP, but maybe he is providing some sort of tunneled backup service. Maybe he's running, maybe this guy right here is a DMBPN hub, and maybe these are spokes all the way down the line. I know I'm in the way. Let me jump out of the way. Maybe these are all spokes. And you have this guy right here is a firewall. Routers are not known to be great remote access VPN gateways. They're just not. Do they support it? Yes. Are they good at doing it? Meh. I wouldn't put my money on it. I'm going to throw a firewall into the mix for whether it's Palo Alto's Global Protect, whether it's Cisco's AnyConnect, or using SSL VPN, whatever the case might be. Maybe you're using Fortinet and the Forti client, or whatever other platforms are out there that you might use. Juniper with, I believe it's the Pulse Secure client. So you have a bunch of different options out here. So maybe this guy right here is your remote access firewall. And maybe you got a couple of them. I'm just giving you a high level breakdown as to how this might come into play. But then you deal with all that. So you terminating the internet on two different routers and getting this up and running to where it needs to go. You have two different routers connected to your WAN for high availability and peering off to the rest of the network. Now this would be a module all in of itself. You have your internet module, and then you have your WAN module. Now we haven't even gotten to the next step. We haven't even talked about where the users plug in. We talked about the DMZ. We talked about maybe this is the data center up here, something like that. And then you connect. Let's do distribution here and distribution here, and do another one down here. But let's say we have A, and A, right? So we have, we have a bunch of connections coming down to all these guys, and same thing here. And then we have a connection coming down to all of these guys. As you can see, it can get messy really, really quickly. But you might say, why do we need that much redundancy? Well, it's always better to have more redundancy than you need. But I'm losing track of all my wiring because it's getting so crazy. Let me do this. This will be easier to manage. There we go. As you can see, with all lines drawn, there's a lot of connectivity. And again, this would be your LAN, where all of your users plug in, where maybe you work. And maybe you have another one over here that's for development or whatever else you want to have. Maybe you put dev, or you put, whatever else that's out there for users to allocate. But you have your core. Now your core switch, obviously you're going to want to have a box that's really, really beefy, right? Well, that's going to be definitely something that you want to take into consideration, because that's going to basically be the engine behind that. Now, with that being said, now that I've got this all drawn out, what are some of the things that you would need to take into consideration for all this, right? So let's assume for the moment that we need dynamic routing. Obviously, this is a much larger environment. So we have this all set up. What do we need to consider for connectivity? Obviously, we're going to need dynamic routing, right? So let's say I'm a big proponent of OSPF. So what I would do is, let me go ahead and switch my color over to be something different. Let me go over to yellow-green. And let's say we run OSPF over everything. So we'll say OSPF is being ran everywhere. And I prefer OSPF. It's one of my preferred routing protocols inside of the campus. I just happen to like it. And one thing that you could do when it comes to this type of stuff is you can go through and put this guy here in all these connections. Let me just draw a line here for all this stuff right here. All this one big green circle, this would be area 0. This would be the backbone. This would be area 1. This would be area 2. This would be area 3. This would be area 4. This would be area 5, so on and so forth. Okay, so why so many areas, right? So let's try to clamp this down a little bit more. So this would be another area. This would be an area. This would be an area. this would be an area, and this would be an area. Well, why do that? Well, because it provides us a level of hierarchy, right? We're trying to take the connectivity in the network and we're trying to carve it up so in the event that there's a problem in one part of the network, it's not adversely affecting other parts of the network. So we have dynamic routing. And what's cool about this is I can configure the access layer, for example, to be a stub area, which means that on the distribution layer switches, I can basically configure them to be a stub, which means that they'll only receive a default route, right? So I don't need them to know about anything advanced in the routing table. They just need to receive a default route, and they're like, okay, we're good. The core switch, or the core devices, whether it's router or switch, will have all of the routes, right? He'll know about everything. Maybe up here, we don't do anything at all. But there's a number of other scenarios where I might need redistribution. And if I need redistribution, obviously I would need to use the not so stubby area in order for that to work. But Rob, what about DMBPN? It's not a good idea to run OSPF over DMBPN. I agree with you. What you can do here, let me go ahead and switch my color one more time over to, let's say, orange. Let's do this. Let me go ahead and jump out of the way. Maybe we use, from the DMBPN hub, maybe we run a bunch of, let me just draw a cloud up here. And then we connect everybody to this guy right here. So all these orange lines are my my tunnels connecting to this cloud. And then what we do is we run EIGRP over this. Well, that's great and all, and then we need to do redistribution. So we need to redistribute from EIGRP into, and vice versa, into OSPF to do mutual redistribution on this router. But Rob, what happens if we have two internet edge routers and we have two hubs? That's fine. We can do that. That's one thing that could definitely be deployed if it's necessary. And if you need to do something like that, it's totally plausible. But it really needs to be taken into consideration with how you're going about doing something. So if you need to do redistribution and you're going to be putting on two internet edge routers, you would have to do some sort of manipulation in the redistribution configuration to say, okay, which router do I use? Do I redistribute and make both routes look the same? Or do you say one router is more preferred or is the preferred egress path in that particular term? So there are a number of different options that are available to you in DMBPN. I've spent a large amount of time going into that. So if you go look at some of my older DMBPN content, you'll see what I'm talking about. But this is basically how this stuff comes into play. This is where you really have to understand the high-level networking components that go into that. So what about NAT? I need internet access. No problem. You would configure your firewall to do the natting, and it would NAT to a public IP, or you would just pass it through, and the connection between the firewall and the router right here, this guy would just be a routed segment. You would take the traffic in on the firewall on the inbound interface. You would do, a NAT it over to, you don't even have to do NAT on the firewall. You can do NAT on the router, or maybe you're doing NAT here, and then you send it to the firewall to do the inspection, or whatever the case might be. There's a number of ways of doing it. That in and of itself is a whole design use case. Do you NAT on the firewall, and then once it's been NATed over to a particular IP address, maybe you NAT from from private to private, because you don't have to do NAT just private to public, right? You don't have to do it that way. You can NAT it from, say, 10.1.17.6 to 192.168.21.7, and then the router will say, okay, anything coming from 192.168x gets NATed over, right? So you can NAT everything over if you'd like. It's up to you on how you want to do that. So there's that particular use case. And then you have the VPN connectivity. So for example, I've got remote access users that are sitting at home over here. Let's say we have a home user, and the home user sets up a VPN connection and then terminates on the firewall. While the VPN connection comes online, by default, ASA firewalls that are running AnyConnect will automatically generate a RRI, or a reverse route injection static route. It's basically a /32 host route that says, okay, if you want to get back to whatever IP address has been assigned to the end user at home, you need to take that static address and you need to propagate that into whatever your routing protocol is, so that that information can get propagated to the rest of the network. You propagate that information and then it goes to wherever it's got to go. So that means it would get disseminated to the rest of the network. And then you'd be able to go wherever you need to be. So you've got that, take that into consideration as well. Would you NAT on your firewall that's also running remote access VPN? You could. You could have these guys basically taking over for each other. You could even make this guy right here a DMVPN hub on this router right here. You can make him a DMVPN hub. You just have to make sure that on the firewall that you pass through the GRE tunneling config to make sure that as it comes inbound, you just pass it through. You know, you just have to make sure that that happens. Whether it's IPv2, ESP traffic, whatever the case might be, you just have to make sure that it gets passed through the firewall so that it's like, okay, if I have inbound connections coming in, I know to allow it to go through the firewall and land on the router. That's also an option. So there's a lot of different capabilities to take into consideration when you're dealing with all this type of stuff. This would be I'm actually, now that I'm looking at the topology, I think it would be kind of cool to create a kind of a course or a series of videos that cover a lot of the design use cases. I was actually reading through the CCNP enterprise design and reading up on that, and I'm like, the more I've been reading up on it, the more I'm kind of in the idea of why not create a series of videos around network design, cover a particular network design use case, and then if obviously if I can support it, I would do some demonstrations on how to do that and really help all of you guys out in terms of the scale and how that would actually look on the command line. And I could probably pull this off in Eve. I think I could totally do that. And then set up some internet connectivity, do a firewall, do a router. Actually, now that the more I'm thinking about it, I think I'm going to do that, because I think that would be really cool, not just to talk about it, but to actually dive into it and go through the process for that. And because then this would help all of you that are trying to understand the concept of dynamic routing. I can take an actual campus LAN for those of you that are working on the enterprise space, spin up an enterprise environment, and then go through all the configurations that are necessary in order for that to take effect. I think I'm going to do that now that I'm looking at this, and I'm like, huh, I'm kind of liking this. It's actually kind of cool looking, because at the end of the day, you really have to know what it is that you're trying to accomplish. And before I wrap up, let me go ahead and talk a little bit about IP addressing schemes. Whoops. There we go. So IP addressing schemes are really, really important. So I'm going to leave the topology the way that I've got it drawn out. But let's talk about this from the perspective of you have the option of using multiple address schemes internally, right? You can use the 10/8, you can use the 172.16/12, and you can use the 192.168./16, right? So you have all these different RFC 1918 address spaces. All that is great. Well, that leaves you some room for, like, okay, what do I got to do? So let's actually take into consideration what this is actually saying. When I say a /8, I'm saying that I'm looking at a subnet mask of 255.0.0.0, right? Which means this is where the 10 dot is going to come into play, and the 0.0.0 is going to be open for the second, third, and fourth octets. Which means that in the second octet here, I can have 0 through 255 as my IP address. In this one here, the same thing. I can have that as 0 through 255, and the same thing, or that doesn't apply here in the fourth octet, because that's actually a host IP, right? So this can't be, it'll be 0 through 255 again here, but this will be for hosts. This will be for subnets and subnet, right? Well, I actually don't do that in this one here. So this one here correlates to this. This one here correlates to this. Let me draw this a little bit better. This one correlates to here, and this one correlates to here. All that's well and great, right? Well, I'm actually a bigger proponent, instead of saying in the second octet right here, instead of this mapping to a subnet, map this to a location. Okay, so this is location, and then each location would have 256 subnets, or right around 65,000 IP addresses per site. I mean, obviously you wouldn't do that for every customer or every site, right? Because you might get a small site that might only be 50 users. So obviously you would have to carve that up. You could give your much larger sites a /16 address range. So you would do something like here, this guy would be a /16, this would be a /16. Maybe this guy here is a /24. Maybe this guy here is a /24. So you don't have to, you'd have much larger sites. You could have theoretically, say 100 of these, 100 really big sites. So the first 0 through 99 are /16s, and then 100 through 255 are /24s. So that gives you, you know, way more sites. And then obviously if you needed more than 250 IPs or 250 users, or 250 endpoints, then you could obviously add that up and do a /23 or /22 and add as you're going along. But those things come into play and how they all work. So this all being said, this is where a lot of the stuff comes into play. So this is why I wanted to draw it out the way that I'm doing. Now that I'm thinking about this, I'm thinking now more or less to do a design meets, like take the design for CCNP exam and marry that to Encore and a NARCI, and eventually SD-WAN when I get there, and marry it together and do design and Encore and a NARCI and SD-WAN and things like that, and go through that. That's kind of what I'm thinking now that I'm looking at it, because I actually like the way this is playing out. Because as you can see, this would represent an actual enterprise environment. That would actually be pretty cool to go through and demonstrate and show you guys how to do all that stuff, and have a home user connected at home, and then you need to be able to set up the firewall and the router configuration to do the NATing, and set up a couple of endpoints that need to be able to reach the internet and things like that. That I think would be kind of cool to get that up and running. I think I'm actually going to go do that now that I'm thinking about it, because I think that'd be a cool topic to discuss into. So let me know what you guys think. Put your comments down in the comment section below if you've gotten this far. And I will talk to you guys in the next video. Thanks so much for stopping by, and I'll catch you guys later.